sliding through the floor. But I do know what it was too. This one could be with you. What a wonderful world this would be.
Good afternoon, everybody, and welcome to Mr. K's 30 Minutes of Math. I have a new background today showing off RPS. Pretty excited about that. And let's get started. So I'm going to go ahead and shift over to our riddle from yesterday. So hold on one second. All right, let's get to it. And as you recall, we had a Star Wars riddle in honor of May the 4th. May the 4th be with you. And we had different Star Wars characters that were added up and multiplied to equal other characters. And the question was, what do we have for that question mark? So let's see what we've got. All right, folks are already writing in. Delilah saying it's 26. Ezra saying it's 26. Fantastic. Let's go ahead and check it out. Well, we start up here with these Kylo Rens, and 3 of them equal 42. So one of them would be 14. All right, and then we have Obi-Wan Kenobi and BB-8 equals 17. Let's put that one aside for a second. What we next see is that Kylo Ren equals Obi-Wan Kenobi. All right, so that means Obi-Wan Kenobi here is 14 because we know he's the same as Kylo Ren. So what is BB-8? BB-8 would then be 3. All right, so Kylo Ren is 14, BB-8 is 3, Obi-Wan is 14. And then we find out that Finn equals 1 BB-8 times another BB-8. Well, we know that's 3 times 3. So Finn must be 9. All right, so that brings us to the bottom. We know Obi-Wan is 14. And we know BB-8, where's BB-8, is 3. And we know Finn is 9. 14 plus 3 is 17, and 17 plus 9 is 26. Oh, I just got a reminder. That's not Finn, that's Poe. My apologies for making that grievous mistake about Star Wars. My apologies, my apologies. All right, well, let us get started with our math for today. Oh, there it is. Our answer is 26. All right, our homework from last night, we were converting our fractions into decimals, and we were using place value discs, those little circles to represent each number. And then we were going to write it in decimal form, fraction form, and unit form. So let's start here. We had 4 hundredths. So if we did our little discs, that would be 1, 2, 3, and 4. And so then we could write it like that, 4 hundredths or 0.04. All right, moving on to the next one. We have 13 over 100, and I see some folks writing in. That would be 13 hundredths. So if I did my discs, this is going to be, I need 13 of them. So I'm going to do 10 here, and then I'm going to do 3 more, and they would all have 0.01 inside of them. Okay, so we would have all of these. So that would be 10 of them, 10 hundredths, which we know is the same as 10 hundredths, we know is the same as 1/10. And then we would have 3 hundredths left over. And so that would give us 0.13, which is the same as 1/10 and 3 hundredths. All right, moving down to the bottom, and I see folks writing in. We have 0.41, which I hope you see is 41 hundredths, which we could write like that. We could also write it as 4/10 and 1/100th. By the way, when you write hundredths, don't forget the D right there. It's hundredths with a D. Oftentimes I forget that myself, and so I just wanted to remind you. All right, last we have 0.90, so that's 90/100ths. So we could write that right here. And then how many tenths is that? 90/100ths. Well, we can do that. We know that we could compose those hundredths into 9/10ths, which is why 0.90 is exactly the same as 0.9. You guys should know that because 90/100ths is the same as 9/10ths. All right, well done. I see lots of answers coming in. Very impressive. All right, go ahead and look at this one. We're going to do a area model on this one to show 1 and 15/100ths. 1 and 15/100ths. Well, if each of these squares is one whole, all right, then first we have 1, so that's all of this one. Okay, and then 15/100ths. Now we have tenths, and I need to decompose them into hundredths. So, whoops, I need my marker for that. I'm going to decompose my tenths into hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, not perfectly equal, but you get the idea. And I have 15/100ths in addition. So here's 10 of them. And then 5 more. 1, 2, 3, 4, 5. All right, so 1 and 15/100ths, which is the same if we wrote it in decimal form, 1 and 15/100ths. By the way, the decimal you can read as and. 1 and 15/100ths, which is the same as this, 1 and 15/100ths. And then if we were to go ahead and represent that on our number line, well, let's see, here's 1 and here's 2. So we know it's in between these two. And we have these split up into tenths right now. So you'll see 1/10, 2/10, and so on. And we should have in mind that 15/100ths is between 1/10 and 2/10 because I'm going to draw this line up here. 1/10 is 10/100ths and 2/10 is 20/100ths. So 15/100ths would be right in the middle there. So 1 and 15/100ths would go right there. All right, go ahead and try this one. I know it's a little bit hard to do without the drawing all mapped out for yourself. But go ahead and think it through. What I'm most interested in is this number line. So go ahead and try to figure out where you would place it on the number line. And to give you a little bit of a way to respond, let's do this. Would it be in the blue section, in the green section, or in the yellow section? I'm just picking 3 random sections. Go ahead, work on this one, and then tell me which section you would put it in. Go ahead and write that in, and I'll give you just a little bit of music to think through that one. Okay, welcome back. I see. Sorry about that. I see lots of folks writing in, and it looks like everybody agrees that it is green. Let's check. I've tried to show you what each of these lines represents. It's kind of hard because we're dealing with hundredths, and so it makes it hard to pack it all in there, but you'll see this one right here is 10 hundredths, which, by the way, you know, is the same as 1/10. This would be 20 hundredths, 30 hundredths, 40 hundredths, 50 hundredths. So 2 and 47 hundredths would be right about there between 40 hundredths and 50 hundredths. And so green is correct. Well done, well done. All right, let's try that again. Let's see, 2 and 95 hundredths, would it be here in the green, in the yellow, in the blue, in the red, or in the gray? Let me see what folks think about that one. All right. 2 and 95 hundredths. Delilah writes in gray. Ezra writes in gray. We have a few more coming in saying gray. And I think you are all correct. Well done. 2 and 95 hundredths. Well, right here, that would be 2 and 90 hundredths. So 2 and 95 hundredths would be right about there. Well done, guys. And then let's do B. All right, would it be in the gray, in the blue, in the green, in the red, or in the yellow? Go ahead and write in. What do you think? Where would 7 and 52 hundredths be? Gray, blue, green, red, yellow. Ezra writes in green. Anybody else want to take a stab at this one? Gray, blue, green, red, or yellow? I see more folks writing in green. Let's check it out. 7 and 52 hundredths. Well, we should know that right in the middle, right between 7 and 8, is 7.5, also known as 7 and 5/10, also known as 7 and 50 hundredths. Those are all the exact same thing. So if this is 7 and 50 hundredths, that would be 7 and 60 hundredths. So 7 and 52 hundredths would be right about there. So green it is. Well done, guys. You guys are doing fantastic. All right, time for the joke of the day. Why couldn't the math teacher take a selfie? All right, go ahead. Okay, Delilah writes in because he was on a plane. That actually is a pretty funny one. That's not the answer I had in mind, but I do like it. Are you guys ready for the answer? Here we go. Drum roll, please. The teacher couldn't find the right angle. I think that's a pretty good one. Let's remember our right angles are angles that are how many degrees? Go ahead and type it in. How many degrees are right angles? Right angles. How many degrees would that be? I see folks writing in. Yep, I'm getting lots of 90s, and that is correct. 90 degrees is a right angle. And remember, a right angle looks like a perfect L. Now, it doesn't have to be shown that way. It could be this way. It could be this way. It could be turned any way at all, but it just has to be that perfect L shape. and that always equals 90 degrees. And we mark a right angle by using this little box. That means it's a right angle. So if you see that little box, you know it's a right angle. What do we call angles that are smaller than 90 degrees? Let's say 45 degrees or 23 degrees or 89 degrees. What do we call those angles? I guess we could call them smaller than right angles, but yes, they have a special name, and I see folks writing in. Those are called acute angles, A-C-U-T-E. Well done, guys. And angles that are larger than 90 degrees, 95 degrees, 106 degrees, 172 degrees. What do we call those? That's kind of a funny name. Yes, well done, guys. I see you writing it in. Those are called obtuse. Obtuse. All right, so here's an example of an obtuse angle, or maybe one like that, or it could go the other way. And for an acute angle, it would look like that, kind of smaller than a right angle. Okay, so first couple of questions I have for you today. Let's call that A, and let's call that point B, and this point C, and this point D. So my first question is, where are the right angles at which points? A, B, C, or D? Go ahead and write in. Where are my right angles? Are they the angles at point A, B, C, or D? Go ahead and take a second and write that in. I see a few folks writing in. I see A and D, A and D. I see A and B. All right, we have a little bit of disagreement. Well, let's take a look. A, yes, it forms that perfect L shape, so that is a right angle. And D, same thing, forms that perfect L shape. Now B is larger than a right angle. You see that? Here's the angle. It's a little bit bigger than a right angle, so B would be obtuse, obtuse. And we had somebody write in, they said, I meant D, not B. All right, no problem with that. And what about C? What kind of an angle would we have at point C? Can folks go ahead and write in? So we have two right angles, an obtuse angle at B. And what about C? Would that be right, obtuse, acute? And I see lots of folks writing in, that's correct. That would be an acute angle. Very good. Okay, my next question then is, what is the slope of the line created by this side connecting B and C? What would the slope of that line be? Remember, slope is rise over run. And don't forget to think about, are you going up or down or left or right, to make sure that you have your positives and negatives in the right place. All right, so I see some folks writing in. I'm going to give you just a few more seconds. Let me give you a little bit of music so you can do some thinking. Here you go. Okay, welcome back. By the way, if you were thinking that music sounded familiar, that is Tchaikovsky from the Nutcracker. All right, let's take a look. I have 7 over 4, 7 over -4, a couple of different options. Let's take a look. I'm going to start at C, and let's see what our rise is. Remember, it's rise over run. Okay, 1, 2, 3, 4, 5, 6, 7. That's our rise and our run. And by the way, it's +7 because we went up, and our run would be 1, 2, 3, 4 to the left, so -4. 7 over -4. Now, some people have asked, well, do I have to start at C? Could I start at B and go to C? Absolutely. So let me show, whoops, didn't mean to do that. Let's show what that would be like. And I'm going to use red so that we can see that. Let's say I was starting at B and I'm going to do my rise first. Okay. Well, we'd be going down, which is kind of strange for a rise, but because we're going down, we're going to call it negative. -1, 2, 3, 4, 5, 6, 7. So it'd be -7 because we went down. And then we're going to go across 1, 2, 3, 4 to the right. So that would be a +4. 7 over -4 and -7 over 4 are exactly the same thing. You can actually write it like this. Put the negative sign out in front and just say -7/4. All right, so those are all the same. 7 over -4, -7 over 4, and -7/4. It doesn't matter which way you go. Well done, guys. Well done. Very impressive work. All right, let's do one more. Let's go ahead and get our ruler out, and you can see that this is about 31 degrees. And I'm gonna put, let's do this in red. All right, my line isn't exactly perfect, but it'll do. And let's assume that it crosses right here and right here, and let's call that A, and let's call that B. Go ahead and find the slope of that one. Okay, I am going to see what we have here with lots of 4 over 7, which is great. We also have -4 over 7, also a great answer. Let's take a look and see which is correct. I appreciate everyone writing in. It's helpful to see how you're thinking about things. So let's say I started at A, and I'm going to do my rise. 1, 2, 3, 4. And it was up, so it's +4. And then I'm going to do my run. 1, 2, 3, 4, 5, 6, 7. And it was to the right, so 4/7. +4, but a +7. Now you could go the other way. You could go B to A. So let's try that. We'd go 1, 2, 3, 4 down. So that's -4. And then 1, 2, 3, 4, 5, 6, 7 to the left, which is -7. Now I know this is a little bit advanced, but -4 over -7 is the same as +4 over +7. That gets into negative numbers a little bit more. We can talk about that a little bit later, but those two things are the same. So again, it doesn't matter if you start with A and go to B, or if you start with B and go to A. You just have to keep track of, am I going up or down? Am I going left or right? And another quick way just to remind yourself is, if the line is tilting like this to the right, it's always going to be a positive. And if it's tilting to the left, kind of like that, it's always going to be negative. All right, let's get back to our decimals and fractions just a little bit more before we wrap up today. Go ahead and do these for me, and then we'll be back in just a second. Okay, welcome back. I see so many good answers coming in from Delilah, Jackie, Ezra, so many other folks. Really excited to see everyone participating. Tyrael, fantastic work. All right, let's take a look and just double check everything. 1 and 17/100ths. 1 and 17/100ths. And remember, think of the and as the decimal. 1 and 17/100ths, which remember is the same as 1 and 1/10 and 7/100ths, because 1/10 is 10/100ths. Okay, 2 and 8/100ths, 2 ones and 8/100ths is the same as 2 and 8/100ths. Why is this not 2.8? Why is it not 2.8? Can somebody write in, why is this not 2.8? It's 2 and 8/100ths. Why is it not 2.8? What would 2.8 be? Help me make sure you are fully grasping this. What would be the problem with 2.8? Tyrell writes in, Jackie writes in, because 0.8 is 8/10. Yes, you guys are amazing. Fantastic, fantastic. All right, 2 ones and 27/100ths would be like that, and 2.27. 4 ones and 58/100ths, which is also 4.58. And then 7 ones and 70/100ths, which would be 7 and 70/100ths. Question, is that the same as 7.7? Same or different? Same or different? These two, 7 and 70 hundredths and 7.7, same or different? I see Jackie, Delilah, Ezra, Tyrell, a couple others all saying the same. Yes, well done. They are the same because we know 70 hundredths and 7 tenths are exactly the same. One way to think about this, just think about it in terms of pennies and dimes. If you had 70 hundredths, that's 70 pennies. Or if you had 7 tenths, that's like 7 dimes. You have exactly the same amount of money. You have 70 cents. All right, fantastic, guys. We are just about at time, so I'm going to jump ahead to tonight's homework. Go ahead and take a screenshot of this or a picture or write it down, just like we were doing just now, but just a little bit more practice. So go ahead, I'll give you a few more seconds to get a screenshot or a picture with a phone or to jot it down so that you can work on that tonight, and we will start off tomorrow looking at those. All right, here is our riddle, and you're gonna probably need to take a screenshot of this one and a picture of this one too. I'll go ahead and read it. It's a little bit complicated, but I think you guys can figure it out. It says, Sophie and Caroline made arrangements to meet at a cafe at 2 p.m. Sophie thinks her watch is 25 minutes fast. 25 minutes fast, although it is 10 minutes delayed. Caroline thinks her watch is 10 minutes slow, while it is 5 minutes soon. What will happen if they both aim to arrive precisely on time? All right, so that is a good brain teaser. You got to really think about that one. Go ahead, take a picture or a screenshot or write it down so you can think about that one tonight. And I hope you are able to figure it out, and I hope it doesn't hurt your brain too much. Well, everybody, thank you so much for joining me again for Mr. K's 30 Minutes of Math. It was a lot of fun, and I really appreciate all your participation. Have a great afternoon. Bye, everybody.